Hello and welcome to this CodeRage session on how to build a secure multi-device application using the embedded InterBase ToGo database. My name is Mannarino and I'm one of the Embarcadero software consultants. For the agenda, this session has two main parts. The first part will show getting started with the InterBase database, assuming some of you have never used the InterBase database before, and will show how to add multiple forms of encryptions to an InterBase database. Then the second part will show, using the InterBase ToGo database, an example on how to build a secure multi-device application using RAD Studio C++ Builder, using the embedded InterBase ToGo database to maximize data security with both database and column level encryption. And throughout this session, we'll also discuss and show the multiple forms of InterBase database encryptions, including over-the-wire network encryption, strong encryption AES, database level encryption, column level encryption, backup encryption, long password support, SHA-1. We'll see how to improve application robustness with log-based journaling. And lastly, we'll discuss disaster recovery and automatic crash recovery capabilities with the InterBase database. Looking at the InterBase product edition page, we see there are four distributable versions of InterBase. We have InterBase Lite, InterBase ToGo, InterBase Desktop, and InterBase Server. So during this session, we'll look at both the InterBase Server and the InterBase ToGo database, and we'll see how you can deploy the same InterBase ToGo database on Android, iOS, Windows, and the Mac OS X platform. So what's really cool is that the same database that we create with any of these versions can be used as our InterBase ToGo database. So that's very cool. You can also download a free 90-day InterBase trial or the free InterBase Developer Edition, which is included in your RAD Studio, which has support for up to 20 users with 80 connections. You can download a free trial of InterBase ToGo from the Embarcadero download page to use in a RAD Studio secure multi-device application. Let me take this opportunity to mention this current InterBase special offer. Buy InterBase Server 50 user license or above and get unlimited InterBase ToGo deployments until 2018. So that's 1 full year of free unlimited InterBase ToGo deployments. Using the current InterBase special offer as an example, let me quickly take you through the process of installing and using InterBase XE7, and then we'll show how to get your license file for InterBase ToGo. Here is the Embarcadero licensing email you will receive with your InterBase XE7 server purchase. It has the link to download InterBase XE7 server and the serial number to register your InterBase server. The InterBase XE7 download includes both 32-bit and 64-bit in the same Windows install. So you'll double-click on the Install Windows executable and then follow the instructions as you are guided through the install wizard. Here I can install InterBase XE7 server, the ADO.NET 2.0 driver for InterBase, and the ODBC driver for InterBase, and click install. And now InterBase XE7 server is preparing to be installed. Now I already have the InterBase Developer Edition installed on my machine because it was included with my RAD Studio. So in my case, I'm going to install a second instance. So I'm going to pick a port other than 3050 and an instance name other than GDS_DB, and I'll be prompted during this installation wizard to do that. So click next. Say yes to the license agreement. Since I'm running a 64-bit operating system, I'll install the 64-bit version of InterBase, and I want to uniquely identify this instance using the multi-instance feature. So yes, I'm going to call my instance XE7, and I'm going to give it TCP port 3055. to uniquely identify it from the InterBase Developer Edition that's already installed on my box. Click Next. I'll install both the client and the server, the documentation, and I want to register the server after the installation. I'll leave the default destination folder as is and click Next again to start the installation. And once InterBase is installed, the InterBase XE7 product registration dialog will appear. Here I'll enter my serial number and my EDN account information and click Register. InterBase gets registered, and then InterBase XE7 server is successfully installed, and click Exit. To start the local InterBase server running as an application on Windows, from the Start menu, we can search for InterBase. Here we see two instances of the InterBase Server Manager. One instance is called GDS_DB. This is the instance that gets installed with RAD Studio. And we see another instance called XE7. This is the instance that we just installed. So we'll click on the InterBase Server Manager for XE7. Here we see a dialog that shows the default startup mode, which is automatic, the root directory, and the status of the InterBase server, which is currently stopped. So if I click on Start, it will start our InterBase server. So now we see our InterBase server is currently running. So that's great. If I click on the Guardian properties, a dialog opens showing the location, the version, and the action associated with the Guardian server. Click OK to close the box. And if we look at server properties, we see we're running an InterBase 64-bit SQL server, its location, its version. We get the license that we're using. Here's our 50 user InterBase XE7 server license, its capabilities, the TCP port number that it's running on. So we set this to 3055, the number of attachments, and the number of databases. We'll say OK to close this dialog, and we can X out of the InterBase XE7 64-bit manager. Now that we have the InterBase server started, we can start working with InterBase. We can either use interactive SQL, or we can use the InterBase Console that we call IB Console. So to open the InterBase Console, IB Console, we can search for IB Console from the Start menu. And here we see two instances of IB Console. So we want to find the IB Console that got installed with our InterBase XE7 instance that we just installed. And here it is. So we click on it, and it opens up our InterBase Console. And here we see two instances, one called GDS_DB. This is the instance of InterBase Developer Edition that got installed with RAD Studio. And here's our InterBase instance called XE7, which is our InterBase server with the 50 user license. Let's see how to use the InterBase console to create a new database, add new tables to the database, and insert records into the tables. So the first thing we want to do is log into our local server XE7 instance, and we'll log in with the sysdba user. So every InterBase server has a sysdba user with a default password of master key. And once we log in from database, we can either add a new database or create a new database. So we're going to create a new database. We're going to specify the database name. So we're going to create a pharmacy database to keep track of customers and their orders. So we'll call the database pharmacy, and we'll click save. We'll keep the default options as they are. So the page size and the write mode and the SQL dialect will all keep the same. And we're going to use the alias for the database connection. So the alias name will be pharmacy, and we'll say OK. So now we can connect to our database using the sysdba username with the default password of master key. So here we created our database called pharmacy, Now we want to create tables. So we can use interactive SQL and load a script to create tables and insert. So the first thing we want to do is create some domains. And an InterBase domain is a customized column definition that you can use to create tables. And we're also going to create a table called pharmacy with some columns and insert records into the pharmacy table. We'll create another table called customer with some columns and insert data into the customer table. So we ran the interactive SQL, which should have created our tables. So it created out 3 tables: customers, orders, and pharmacy. And here we have records in the pharmacy table. Here's our records in the customer table, orders table, and here's our records. At the data tab, we see the 2 records that we inserted for customers. So this was a quick look at how to use the IB console and interactive SQL to create a new InterBase database and tables and insert records into the InterBase tables. We could also use interactive SQL for the select statement. So I can say select asterisk from customers and execute the SQL, and the 2 customers, Bob and James, get displayed. So that's all working fine. We can also use the IB console to add an existing InterBase database. So we're going to pick the standard supplied employee database. Which has a few tables. As we look at the data, we see names and salary information. And this reminds us how important it is to keep our data safe and secure with strong encryption. Next, let's look at InterBase and how you can maximize your data security with multiple forms of InterBase encryption. With InterBase, you have these 6 ways to configure and use encryption. You have over-the-wire network encryption, and that consists of 2 parts. One resides on the server side and the other resides on the client side and works to secure the server. You have strong encryption, AES, and AES stands for Advanced Encryption Standard, and this is considered strong encryption. You have database level encryption, and database level encryption encrypts the entire database. So InterBase encrypts all of the database pages that contain user information. We also have column level encryption, and column level encryption is more flexible and specific than using database level encryption. We have backup encryption. So using InterBase database encryption, you can also encrypt database backup files. And lastly, we have long password support, SHA-1. A plain text password length of 32 bytes is supported. Before I get too deep into encryption, let's go over some encryption terms and concepts with InterBase. So encryption introduces a new special user called the sysDSO, and sysDSO is the System Data Security Owner. Now the sysDSO owns responsibility for many encryption related activities. So by design, there is a separation of power between the database owner and the sysDSO, and this is designed to help facilitate secure practices. So some of the key differences we see in this chart between the sysDBA and the sysDSO, and they are: only the sysDSO can create encryption keys but cannot encrypt. Only the sysDSO can set the system encryption password, the SEP. Only the sysDSO can grant encrypt privileges to other users. Only the database owners can encrypt database and columns using the encryption keys created by the sysdso. And lastly, only the database owner can grant decrypt privileges to other users. I mentioned this briefly before, but let me expand here a little bit. There are two levels of encryption in InterBase: database level and column level encryption. For database level encryption, it's used for encrypting the entire database using a single encryption key. With column level encryption, you can encrypt individual columns using different keys with different settings, including password protection. InterBase has two different encryption algorithms. There is DES, which stands for Data Encryption Standard, and this is considered weak encryption. InterBase also has AES, Advanced Encryption Standard, and this is considered strong encryption. Some of the differences between the two are both AES and DES are included with your InterBase license and does not require a separate license. DES has just one key length option, which is 56 bits, and AES has the option of using 128, 192, or 256-bit key lengths. Both support init vector of null and random, and both support pad of null and random, and both support password protection. For the init vector and pad options I mentioned on the last slide, just to explain briefly what I mean by init vector and pad options, you see here the unencrypted row has the name Jerry Barnes, and the yellow spaces after the name is just padding. In the first case, we set init vector to be null and we set pad to be null. So here we notice that everywhere there is an R, the encrypted value is the same letter A. Same thing where we have a letter E. The encrypted value is the same upside down question mark. And because pad is set to null, the padding is also all the same values, the letter S. And this gives us lots of clues about the data. For the second case, we set init vector to be random, and we have padding equals null. Now notice everywhere there is an R, we have a unique encryption, and everywhere there is an E, we have a unique encryption. And because pad is still set to null, we still have the same encryption for all of the padding. For the third case, we set init vector to be null and we set pad to be random. Here we see all the R and E have the same encryption, but the padding is randomized. In the last case, we set both init vector and pad to be random. And this gives us the highest level of security. And it gives us the fewest clues about our data. So all of the R's and E's have unique encryptions, and all of the padding is uniquely encrypted also. So why is encrypting your database important? Let me use our unencrypted employee database as an example, or any unencrypted database. If we were to open up any unencrypted database, for example, using Notepad, we see a bunch of gibberish, but as we scroll through the database, we start to see some human recognizable words. Now I know there's an entry in this database for Mr. Robert Nelson, so let's see if we can find him. So if I just search for Nelson, we see here that we find him. So a clever hacker can find out quite a bit about Robert Nelson and all the data in this database with just a plain text editor. So what we really want to do is encrypt our database. And we want to encrypt with strong AES 256-bit encryption because when data is at rest, it's recommended to be stored encrypted with AES 256-bit strong encryption. Data protection is a key worry for all businesses today. A data breach typically leads to a 4% loss of your customer base, with regulatory fines that can lead into millions of dollars and corrective action plans that require staff retraining, customer credit score monitoring, etc. This all adds up to a rather expensive exercise best avoided, so it's far better to build this in upfront rather than pay for it later. So as we saw, when it comes to data protection, InterBase offers role-based authentication to control access to data inside the database. However, this is just the foundation, and encryption at rest is key to safe storage of data and avoiding the bigger fines if you have a data breach. InterBase offers encryption at rest with fast, granular, column-level encryption across all supported paid platforms. When it comes to backing up your data, InterBase includes strong encrypted backup in all paid editions also. Now, let's take a look at how to encrypt a database in InterBase. There are two ways to encrypt a database in InterBase. You can enable and implement encryption using interactive SQL, or you can encrypt the database using the IB console. So for this example, I'm going to show you how to encrypt the database using the IB console. So for this example on database encryption, instead of using our employee database, I'm going to use the pharmacy database that we created earlier. And just like we did for the employee database, if we open up an unencrypted database in, let's say, Notepad, once again we see lots of gibberish, but as we scroll down, we'll start to see some human recognizable characters. And we know one of the customers in our pharmacy database is named Bob. So if I search for Bob, we find him in our database. So let's say after we encrypt our database, let's see if we could find Bob, or Bob should be totally encrypted and we should not be able to see any human readable text. In IB console for our pharmacy database, we see there's an action called Encrypt Database to encrypt the database. So I'm going to double click that. It brings up the database encryption wizard, and this wizard will guide us through the creation of an encryption key, which will then be used to perform database level encryption on this database. So the steps are: 1, first to provide the sysdso password, and if you recall, that's the data security owner, because he or she is responsible to create the encryption keys. And then we'll establish a system encryption password, and then we'll specify a name and options for the encryption key, and then we'll create a backup key if necessary. So we'll click next, and here we provide the sysdso password. And say next. Here is where we establish our system encryption password for this database. So let me enter my system encryption password and confirm the password. And I can check the external checkbox if I do not want the SEP to be associated with my computer. So I'll check that box. So this system encryption password, it protects the encryption keys that are used to encrypt the database and or database columns. I'll click next. So now, since we're doing database level encryption, I'm going to call my encryption key my database level key. I'll make it my default key. I'm going to check the use case sensitive name. For the cipher, we can either pick DES weak encryption or AES strong encryption. We'll pick AES for strong encryption. The key bit length, we'll pick the highest, 256-bit encryption. And if you remember from init vector and padding, if we set them both to random, this will give us the highest level of security and gives us the fewest clues about our data. Click Next. In step 4 of our database encryption wizard, to be able to backup and restore our encrypted database, we need to create a password protected key. And if we create it now by supplying a name for it and supplying a password, and the cipher and the other parameters of step 3 are used to create the key. So my backup key name, I will call my backup key. I will make it a case sensitive name, and my password, and confirm the password. So I got them correct. Now I can click OK. And at this point, encryption of the database is complete. So that's great. So now our pharmacy database has been encrypted. And like we did before, if we open up the pharmacy database in an editor like Notepad, as we scroll around, we notice that the data is now much more cryptic. There's nothing more recognizable, nothing more human recognizable and readable. And if we search again for Bob, we cannot find Bob because his name is now encrypted. So all of that is great. I also want to encrypt our employee database, but I want to make a copy of the employee database first. So under Actions, I have Copy Database. I want to create a new database. Give it the location and name. I'm going to call it my Employee Column Encrypt Database, because in addition to encrypting the database, I also want to encrypt some of the columns in the employee database also. So we just made a copy of our employee database. Let's go take a look at it. So here is our employee call encrypt database that we just made a copy of from the employee database. And the same way that we did database encryption on the pharmacy database, we're going to do the same to this employee call encrypt database. So I'll double click on the encrypt database action. Give it the password for the sysdso. Database encryption name, I'm going to call my DB level key. Strong encryption, 256 bits. Random init vector and random padding. And the encryption of the database is complete. Next, to our employee call encrypt database. Looking at the employee table, looking at the data. So now, in addition to the database level encryption we added to the database, we now want to add column level encryption to this salary column of the employee table. We want to do this because we don't want every user to have access to the salary data. Only users that we give decrypt rights to the salary column will get salary data. Other users will get a default value of 0. So let's see how we do this. So to start, to our employee column Encrypt database, I added two new users. Right click in the users box and select create. So I created two new users, one called HR employee, and this user has decrypt rights to the salary column. I created another user called new employee, and this user does not have decrypt rights to the salary column. Instead, he or she will get the default 0 value if they ask for any salary information. Similar to how we created our database level encryption key that we call DB level key to encrypt the database, we'll create another encryption key for doing column level encryptions, and I'll call it col level key. And I also selected use case sensitive names. So similar to how we created the database level key, we'll also select AES strong encryption for the cipher, key length 256, init vector, and padding as random. So to do this, we are actually logged in as the SysDSO, the Data Security Officer, because remember, the SysDSO cannot actually do any encryptions, but can create the encryption keys. So we'll need to reconnect as the database owner, sysdba, so that we can apply this column level encryption key that we just created. Now that we have our column level key for encryptions, we can do column level encryptions. So we want to add column level encryption to the salary column of the employee table. So we log into the database as the database owner, sysdba, to allow us to perform some column level encryptions. Because remember, the sysdba is the only one that can perform encryptions. So we select the employee table, and looking at the table, we see that we have a salary column. So we want this salary column to be more secure so that not everyone that has access to the database can see salary information. So we select the salary column and we select alter selected item. This brings up the table editor where we can select the salary column and select edit field. This brings up the field property editor, and from here select column level key for the encryption that we created earlier by the sysdso. Now there's also a decrypt default property. We will set that value to 0, so whenever a user without decrypt permissions selects from that column, rather than getting an error or no permission for decrypt access for column salary, they will get the default decrypt value of 0 in this case. And the encrypted notice shows up in the encrypted column of the table editor, and you can also see it on the encryption column of the column's properties. So here we see that our column salary does have the column level key applied. So that's great. Using the IB console, looking at the employee table under permissions, we could click on our human resource employee, which will bring up the grant editor, and from here we can add decrypt permissions to the salary column of the employee table and click OK. So now, looking at the permissions for the employee table, we see that the sysdba has decrypt privileges, and we also see that our human resource employee has decrypt permissions on the salary column. So that's great. So now we can quickly see what happens when the human resource employee connects to the employee table and tries to select from the database. So to our database, I'll connect as the human resource employee with their password. And now using interactive SQL, we can select full name and salary from the employee table, execute that query. So here we see that we get the full salary as expected for the human resource employee because the human resource employee has decrypt permissions on the salary column. Now let's see what happens when we try to do the same thing for our new employee that does not have decrypt privileges for salary. Let me first disconnect as the human resource employee, and this time I'll connect as the new employee. And we'll run the same query. Select full name salary from employee as the new employee. Execute this query. This time we get our default value of 0 for salary for the new employee. So that's working great. This is the InterBase XE7 server database we have been using that we added both database level and column level encryption. The good news is we can use this same database as our InterBase ToGo database. All we need to do is create our InterBase ToGo license activation file using our InterBase serial number, and then we can deploy this InterBase ToGo database to multi-device applications. I mentioned you will need an InterBase ToGo activation file to use the InterBase ToGo database. So depending on how you got your InterBase ToGo product, such as a trial download or a purchase or a test deployment trial license, you will need its serial number and registration code to license the InterBase ToGo database. This DocWiki link has instructions on how to get your InterBase ToGo activation file to deploy your InterBase ToGo database on multi-device applications. So for example, let me use the current special offer of InterBase ToGo unlimited deployments till 2018 as a way to show you how to get your InterBase ToGo activation file. If we go back to the special offers page, now let's take a look at how to get and use our unlimited InterBase ToGo licenses so we can use InterBase ToGo as our multi-device database on iOS, Android, Mac OS X, and Windows platforms. On the same RAD offer page, we see a section on how to qualify for all-you-can-use InterBase ToGo. So we already installed and registered our InterBase server license. So now we can click here to redeem our InterBase ToGo license. This takes us to a page where we enter our InterBase server license, and we can click the Get Free Product button. Now we need to enter our Embarcadero Developer Network login credentials. So I'll enter my email and my password. And then I can click the login button. And here we get to choose our free product. So in our case, we want to pick the InterBase XE7 ToGo Edition 1-year deployment license. Make sure the email address to redeem is correct and click the redeem button. And here we are asked to make sure we want to redeem our InterBase XE7 ToGo Edition 1-year deployment license, and we'll say confirm. So the request was successful and we've been emailed our InterBase ToGo deployment serial numbers. Activate the license, we go to this web link and we enter in the serial number. And then we can click next. And this takes us to the product registration page where we can click the register button that'll download for us our InterBase XE7 activation file that we will use with our InterBase XE7 ToGo databases for deployment. And here we see our reg.txt file, and this is our InterBase XE7 ToGo license file that we will use. Next, now that we have our InterBase ToGo activation license file and our InterBase ToGo database file, let's see how to build a secure multi-device application using this embedded InterBase ToGo database. Now that we have our InterBase ToGo deployment license, let's look at how to build a secure multi-device application using RAD Studio C++ Builder and our InterBase ToGo database that we just created with both database and column level encryptions. We created this app starting with a new multi-device application C++ Builder tabbed application, which gave us these 4 tabs to start with. This InterBase ToGo application shows embedded user security and encryption to manage access to private data. Along with being password protected, the data is also encrypted on disk to prevent reading the database file for clear text. The app has 2 users embedded in the database. We have a human resource employee and we have a new employee. The human resource employee is allowed to see the employee's salary column, but the new employee is not. This is because we added decrypt permissions to the salary column for the human resource employee, but the new employee does not have decrypt permissions to the salary column, but instead will get a default value of 0 for salary. Using 2 different connections to the database, we can show what you get to see when connected to our embedded InterBase ToGo database that has both database and column level encryption. Now, an InterBase ToGo application can use FiredA, DB-Express, or InterBase Express components to build InterBase ToGo applications. This application is using FiredA to connect to InterBase ToGo database. We have 2 FiredA connections to our encrypted InterBase ToGo database. One is called FiredA Connection HR, and this is connected to our employee encrypted database. For the HR connection, we pass in the username and the password for the human resource user that has decrypt permissions on the salary column. And the FiredA connection for the new employee connects to the same encrypted employee database, but has the username and password for the new employee user that does not have decrypt permissions on the salary column. Let me run this application as a 32-bit Windows application and we'll see what it does. Then we'll come back and take a deeper look into the code. So here's our application running as a Windows 32-bit application. The Info tab has information on what the application does, displayed in 2 memo components. The Database tab lets us connect to the database as the human resource employee and as the new employee at the same time. The human resource connection connects as the HR employee user, and the employee connection connects as the new employee user. Selecting the HR department tab, we see the full name of our employees and the salary of the employees because, recall, we gave the HR employee decrypt permission on the salary column, but when we select the employee tab, we see the full name of the employees and we see 0 as the default value for salary because the new employee user does not have decrypt permissions on the salary column. So all of this is working correctly, and it's using our embedded InterBase ToGo database with both database and column level encryptions. This app also uses two FiredA Query components. So if we look at the FiredA Query component for the human resource user, it has the query select full name salary from the employee. And when we execute this query, because it's using the username and password of the human resource user, he or she gets to see the salary information because the human resource user has decrypt permissions on the salary column, so that works great. If we look at the FiredA Query for the new employee, it's the same query we are running, but in this case, when we execute this query, because we are passing in the username and password of the new employee who does not have decrypt permissions on the salary column, so instead of getting salary data, instead we get the default value of 0 that we set when we created the column level encryption for the salary column. So all of this is working great. Looking at the OnSwitch event for the T-switch for the human resource employee, we see that we are setting the property for the username and the password for the FiredA connection to be the human resource employee, and we're also setting the FiredA query for the human resource user to be active. And we do the same thing for the switch for the new employee. We set the property username and password of the FiredA connection to be the new employee, and we also set the FiredA query for the new employee to be active also. To define the location of our InterBase ToGo database on mobile devices, we are using the forms on create event. So if we are not running the application on Windows, then we are using the tpat get documents path to return the path to the directory where the user documents are stored /interbase / the name of our InterBase ToGo database. On Android, the tpat get documents path returns the Android documents folder, which is ./assets/internal. And for iOS devices, the tpat get documents path returns the iOS documents folder, which is startup/documents. And this is where mobile devices will look for to find the InterBase ToGo database. So up to this point, we have been using InterBase on our desktop. This means that the actual database is located on your local hard drive. On mobile devices, the application is sandboxed, and typically you can only read and write data that is located in the Documents folder for an iOS device and internal storage for an Android device under your application folder. So to connect to a local database on mobile, we need to perform a few actions. So let me show you what those actions are. For our mobile devices, we need to deploy both our InterBase ToGo database and our InterBase ToGo license file. To make this easy for us, we can use project deployment, and we can select all configurations Android platform. We can use the Add Files button to add both our InterBase ToGo database file and our InterBase ToGo license file. Here we added our InterBase ToGo database file, and for the remote path on our mobile device, we set it to Android's Documents folder, which is the internal storage location for Android, which is ./assets/internal. And we do the same for our InterBase ToGo license file, and we give it the same remote path of /assets/internal. And we could also use the deployment manager's Add Featured Files button, which gives us a nested list of database drivers and libraries that can be added to the deployment list. And similar for iOS devices, either iOS 32-bit platform or iOS device 64-bit platform. Here we do the same thing. The InterBase ToGo database file gets deployed on the remote path to the iOS device documents folder using the remote path, which is startup/documents, and we do the same thing for the InterBase ToGo license file. Deploy it on the iOS device to the remote path, which is the iOS documents folder, which is startup/documents. So those are the files that need to be deployed on the mobile devices to allow you to use InterBase ToGo with its license file on mobile devices, iOS and Android. To display our database values on our mobile devices, if I go back to the Design tab and I bring up my layout, if we look at the HR department tab, here we see we are using a list view aligned to the client to display the values from our employee table. And using Visual Live Bindings, we see that we take the results from our FiredA Query, the FiredA Query for the human resource employee, and the full name column will get displayed on the list view in its item.text property, and the salary column will get displayed on the item detail property. And we do the same thing for the employee tab. The full name of the FiredA Query will get displayed on the item.text property of the list view, and the salary column will get displayed on the item.detail property of the list view. Now let's take the same application we ran on a 32-bit Windows application and build and deploy it to an Android device, and we'll run it on an Android device just to see that it works exactly the same way. So I selected my Android as a target platform project. I will build all projects. So the same application we built as a 32-bit Windows application without making any code changes, we are now creating an Android version of the same application. The build will create the Android APK file that we can load into an Android device, and we can run it on an Android device and see that it works the same as our 32-bit Windows application. So the project has been built. Now we can load the APK file to an Android device. So here is my C++ builder InterBase ToGo encryption application deployed on my Android Nexus 7 tablet. Let me tap on its icon to start it. So it brings up the app with the first tab of info, which gives us information about what the application does. So next I'll tap on the database tab, and here's where we can connect as the human resource employee and also connect as the new employee. So now we have two connections to the same InterBase ToGo database embedded on this Android device, so that's cool. So now when I select the human resource department tab, we see that we get our full name of our employees, and we also get salary information, because recall we gave the human resource employee decrypt privileges on the salary column, so he and she can see the salary information. But when I select the employee tab, the new employee does not get salary information because we did not give the new employee user decrypt privileges on the salary column. Instead, they get to see a default value of 0. So all of this is working great also on an Android device and also using our embedded InterBase ToGo database with both database and column level encryption. So all of this is working great. Recalling our agenda, there are a few additional forms of InterBase database encryptions that I'd like to spend a few minutes to briefly cover: over-the-wire network encryption, backup encryption, long password support, log-based journaling, and disaster recovery and automatic crash recovery capabilities using the InterBase database. First, let's look at using journal files and log-based journal archiving to add an additional level of database protection and to improve application robustness. And by doing log-based journaling, you get disaster recovery, including automatic crash recovery capabilities. We know that organizations are getting more dependent on their data to run their businesses. With the amount of data being amassed at a blistering rate, it has become important for businesses to implement a disaster recovery plan. InterBase has disaster recovery for remote archival and retrieval. An incremental dump gets your data backed up quickly with minimal impact on your online database services. So let's look at InterBase's journaling, journal archiving, and online full and incremental dump facility to give you disaster recovery. Disaster recovery. So let's say, for example, it's 5 p.m. on a Friday, just before a long 3-day weekend, and your database server crashes. What do? No worries, because if you are using InterBase's journaling, you'll get automatic crash recovery, and that's great. We'll see how InterBase uses the checkpoint interval to determine how long it takes InterBase to recover after a server crash. And if the server crashes, all of the changes in the cache will be lost. But this is okay, because the changes were written synchronously to the journal, which stores them on disk, but not in the database. When the server restarts, it must read all of the journal files and copy the changes in the journal to the database to bring the database file up to date. So the more journal files there are, the longer this will take. So performing frequent checkpoints means that the changes in the cache are written to the database frequently, so fewer changes are kept in the journal. This in turn means that fewer journal files are required and recovery will take less time. The typical InterBase database, like the sample employee database we used in this webinar, does not have journaling added. So we want to add journaling to our employee database, either using the IB console or using DDL statements to start journaling on our InterBase database. So here is what the IB console wizards and the DDL looks like. So we introduced some new DDL language: create journal and create journal archive statements. Create journal is how you initiate journaling, and journaling uses write-ahead logging technology. A write-ahead log is a file that captures your committed database changes. It gets written in sequence and synchronously. We always write synchronously. You cannot overwrite and say deferred or asynchronously. And this function of journaling can be used quite apart from using the journal archive, but then you don't get archive data, and then you are not prepared for disaster recovery. Many competitive databases run this way. They use write-ahead logging technology. This journal database could be used standalone, but that is not why we created it. We created it to be used as a vehicle to achieve our disaster recovery backup facility. The create journal statement has a number of clauses. We have length in pages. Similar to a second database file length or database shadow, if you are familiar with those subsystems. It just says how many pages do you want a typical journal file to be. We have checkpoint length and checkpoint interval. So for checkpoint length, journals have a checkpoint length, and as you can imagine, since you are writing to the journal, you are not necessarily writing to the database. So at defined intervals, you want to be able to say, okay, give me everything I've written to the journal, and I want to checkpoint, make those changes permanent inside the database itself. And this gives a length after so many writes to the journal. How frequently should I checkpoint to the database? So you can do it in terms of length, or you can also do it in terms of intervals and say, okay, maybe activity slows down and you have all of these changes that are in the journal, but they have not yet been checkpointed. Well, if no one is using the system, they are never going to get checkpointed. So this interval says after so many seconds, checkpoint as well. So the checkpointing will happen as a minimum of these two clauses, either checkpoint length or checkpoint interval. Database page. In fact, in this particular database, let's say we set the page size to be 3 kilobytes. So here we allow a large number of changes to be written to a particular journal page. For page cache in buffers, additionally, inside the server's memory, it will allocate journal cache buffers. And basically, we transfer the incremental changes to the database pages from the database buffer cache to this journal buffer cache. Timestamp name. The timestamp name has to do with the format of what the journal files look like. So this is the default clause, and you will see in the next few slides what this really looks like. One more item, we have the create journal statement, and this gives you the prefix for what a journal file will look like. So to this, we will add a suffix that consists of a timestamp, a journal sequence number, and then a file extension that should look meaningful to someone looking at these files. The create journal archive. The archive is a system file directory. So there is no special storage container. It's just a file system directory where we want to archive the files. Creating the journal. So after running the create journal wizard, or the DDL, gives us these files. So we see our journals and we see our archive files created. In journals, we created 2 file entries. An IB journal file, which is a markup file. If we open up this file, it's very simple, just giving you the database that this journal directory is being used for, because if you don't give them good names, then it might be difficult to make the backwards associations to the database. Also, the InterBase journal archive file from the archives folder has the same database information. We also see that we already have our first journal file created in the journals directory, which is being used to record the information that is being written to the main database. So we see the prefix and the timestamp in year, month, day, hour, minute, second, and then a sequence number followed by the file extension of journal. So it's good to know what time these journals are created to be used for disaster recovery, because we have the ability to recover until a timestamp. So if you know when a database becomes bad due to maybe hardware corruption or a software failure or a user error or some harmful or benign event, etc., you might know that if I can recover my database before a certain time, then I'll be in an okay state. So by default, disaster recovery recovers everything until it possibly can, but you also have the ability to say, I want to recover until a certain time. Here's a visual on what InterBase journals and journal archives looks like. So let's say I'm running 10 clients updating various warehouses and districts, and this will generate some data for us. So let's say this adds 12 megs of data to the journal file. So this is great. We have journaling turned on and running, but we are not backing up anything to the archive file yet. One of the things to start with is you just don't need the journals. With write ahead logging, you put the database on one drive and the journal files on another drive because the journals are sequential files. You don't want the heads moving around competing with the database. Likewise, the archive should be on another place on the network storage device if we are worried about machine failure. But the archive can also be on the same computer if you worry about disk failure. Then you can use a third drive letter. So the database, the journal, and the archive each should go on its own drive, or the archive on a network storage device. So we can back up our journal files, but what are we restoring from if the database is gone? So for disaster recovery, let's start by archiving the database first. And if things are now going correct, we're now copying from the main database in our employee directory, and we're doing an online database dump, a full dump, which is full consistency, and we are getting exactly what the database looked like at that moment. Even though it's being updated by the 10 clients updating various warehouses and districts and other scripts we are running. So that's the magic of online dump. The main point is we are creating a starting point from where this database is going to recover from in the future. Here's an example of point-in-time recovery. What this is saying is I don't want to actually go to the end of all the journals. I only want to go up to this point. So it will go to the dump, copy the dump to the recovered database, and then start applying all of these entries up until this timestamp. Everything in the journals, all the journal entries have timestamps. So that's the means by which all of this works. Lastly, let's look at over-the-wire network encryption or network traffic encryption. So why is this important? Because as enterprises become dispersed geographically, an increasing number of applications are accessing databases over unsecured networks. Data transmitted over the network is susceptible to sniffing and integrity attacks. The confidentiality and integrity of data transmissions over the network can be ensured by encrypting the data. Typically, data encrypted at the database or column level is not encrypted during the transmission process. Over-the-wire encryption, however, allows you to do just that, encrypt data as it is communicated over a network from a client to a server. So if you use over-the-wire encryption, you must encrypt network transmissions with the same strength as was used to encrypt the database or columns, and you can either use weak or strong encryption. So information sent to an InterBase remote client from a database server is unencrypted during the transmission process, even when the data was encrypted prior to transmission. So this creates an opportunity for a security breach. So to prevent against this, we can use over-the-wire network encryption feature of InterBase to encrypt data during the transmission process. Now, we don't have time in this webinar to show the over-the-wire encryption details, but look at the InterBase operations guide for details on how to set up over-the-wire encryption with sample configurations to enable and implement over-the-wire encryption across your network. Or you can use the InterBase IB Console over-the-wire encryption wizard as we see on this slide that opens up the over-the-wire wizard. So this dialog allows you to create an over-the-wire encryption of the client-server configuration. And by checking the Use Default configuration, this means that InterBase will use the IBSS config default as is. This ends what I had time to cover in this CodeRage session. We got to see multiple forms of InterBase database encryptions, and we saw how to build a secure multi-device application with RAD Studio using the embedded InterBase ToGo database to maximize data security with both database and column level encryption. Here are some additional resources for details on how to use the multiple forms of InterBase database encryptions and how to build secure multi-device applications with RAD-Studio using the embedded InterBase ToGo database to maximize your data security. Now, let's open this session to any questions you might have.